center of mass and center of gravity. These two terms are almost similar in many respects and are in short known as CM and CG. Center of mass is the point where the total mass may be supposed to be concentrated. We can suppose the entire mass of the whole system at a particular point that will be known as center of mass. Similarly, center of gravity is the point where the total weight of the body is supposed to act. There goes one very important formula. You are having in your system masses M1, M2. They are at positions x1, x2. Means they are forming a system and you are interested to locate the center of mass. Then here's one formula for it. This could be sum up in this form. Sigma. Sigma stands for summation of similar terms. Likewise, you can go one step further short. It could be written as sigma mx upon total mass, or even it's written sometimes in integral form x dm. For m, you can also write integral dm. What is this m? This is the total mass of the body or the system. If we are writing here, you see, we have used vector form of these things. That means we have chosen here position vector. You might take x coordinate, y coordinate, z coordinate, or even the position vector in the place of x. It is applicable for all the three axes, means for y also, for z also. Now, if you consider a system of two masses only, two masses, this is m1, m2, and they are at a distance, suppose, a small r. They are having the distance between them is small r. Then obviously they are forming a system and you can locate the center of mass. Suppose center of mass is here, say point C. Now if we consider this point as origin, x becomes 0 for m1 and here it becomes r. By using the same formula m1, x1, m2, x2, you will find here xcm, m1, x1 is 0 and then m2, x2, this is r upon m1 plus m2. What it becomes? xcm m2r upon m1 plus. This is the location of center of mass from origin. That means suppose we write it as R1, this would be R2, say it is R1, R2 will be M1R upon. See, the interesting thing is the ratio. This is M2 upon M1. I have written here, two masses are here, M1, M2, R1, R2. The center of mass is going to lie on the line joining them. Line joining them. Hint is given here, closer to the heavier mass. How would you derive that thing from this result? You see, if this is heavy, means M1 is heavy, then it is naturally is smaller. Means with the heavier mass, center of mass will be closer. It is also said like this. For whenever there are two persons, say one is 90 kg and one is hardly 40 kg, they are standing on a base, then CM will be closer to the heavier mass, heavier person. And here you see, they are two kids on seesaw arrangement. We have shown here, this is CM. CM here is obviously on this axle. This person is heavier, so he is sitting closer to it. Because we know CM has to be closer to the heavier object. And then there goes another thing, that you are having many masses together. There will be one center of mass. If you try to find the moment of all the masses about center of mass, that will be equal to 0. Similarly, if you are having CG, this was about CM, moment is 0. And at CG, the gravitational torque will be equal to 0. That means if at the CG, you try to find out the moment of all the weights, the total will be equal to 0. In short, we say that gravitational torque will be equal to 0. Here we have used two terms, center of mass and center of gravity. Both the terms are same if the object is of a smaller size. In our lab, in our daily discussion, normally we use the things that are of a smaller size, and CM, CG will coincide. But if you are talking about big things like hills and many other big things, then their CM and CG will differ. Remember, these points, when I am talking about a block, I may say CM, I may say CG, both the same. These things might be on the surface, inside the body, even they could be outside the body as well. See, for different objects, CM has been shown here. CM can be removed only by the external forces. This is very important thing, very important feature of CM, that in order to displace CM, shift CM, one always needs external force. Internal forces can never disturb the CM. I'll tell you one example. This is given here also. Suppose a person is standing on the boat, and see, this is boat, and I'm standing here. Now if I move this way, the boat will go backward and CM will remain where it was, because boat and myself both are forming a system. We are applying the force on each other that amounts to internal force. Here there is no external force, so CM will not shift. In order to maintain this very fact, when I move forward, the boat itself goes backward.